Thank you. Today we're moving from medical towards education. We're very lucky to have two gentlemen from Burma and from Mexico. Doesn't look Burmese, but he'll tell you later. Coming out of a larger context here, a decade ago, you see more than 500 school implementations in communities out of one laptop per child. Actually, probably a third of the people in this room, I think, are somehow loosely connected to that one laptop per child. Tomorrow we're going to do more business models, or boxing models, or scraping, and then finally Thursday we're going to move on to making millions of brighter minds. Thank you, Cesar, and thank you, Josh.
Okay, hello everyone. Today I'm going to be talking about Kids on Computers. Kids on Computers is a non-profit organization that partners with schools to create computer labs. A little bit about myself. I'm a software engineer originally from Chiapas, Mexico, in southern Mexico. I had the opportunity to become a software engineer, come in touch with free software and open source, and getting involved. Now I live in California, and I've been volunteering with Kids on Computers since 2016. Okay, so who is Kids on Computers? Kids on Computers is a non-profit organization that was founded in 2009 by Thomas Peters and Stormy Peters, who you might recognize from the Guillaume Foundation in the early 2000s. They started the non-profit with the first computer lab in Oaxaca, but it has expanded towards other countries like India, Morocco, Nepal, Ghana, Argentina, depending on where the volunteers come from or where opportunities arise. Okay, so today I'm going to be working particularly about the work that Kids on Computer that we have been doing in Oaxaca, Mexico. Oaxaca, who has an idea where Oaxaca is? Okay, that's great. It's southern Mexico. I don't have a map, but if you think of Mexico, you go all the way down almost like where Guatemala is. And you might not know where Oaxaca is, but you might recognize mole. If you like good food, you might have eaten mole before, or you might have seen the art from Oaxaca, or maybe you have eaten grasshoppers, because we eat grasshoppers in southern Mexico. No, they are dead and nicely marinated. It's a pretty good source of protein, just so you know. All right, so, but besides being such an amazing culture, it's also one of the poorest states in Mexico. They say Chiapas and Oaxaca compete to be the poorest state of the country, unfortunately. But to the point that, some of these communities, they have dirt roads, the schools are pretty humble. You can see Abdi Katri and Gustavo Silva from Kids on Computers there talking to a prospect school that wants to partner with Kids on Computers. And unfortunately, also Oaxaca has had several conflicts with the government, to the point that the government sent the federal police and they shut down multiple innocent people. All right, so, but something that I have recognized, or not recognized, but identified from the Oaxacan culture is this focus on the community. The community comes, and this focus comes from the native culture before the Spaniards came to what became Mexico. And there's these two concepts called the tequio and the guelaguetza. Tequio is this idea of doing work that benefits the whole community. And it really touches a note on me because the whole work that we do, yourselves and the people in Kids on Computers, is work for the community. And here you can see Hermes, which is he's doing training for the teachers on the school such that they know how to use the computers so that they can use it with the curriculum in order to incorporate it for the usage of the kids as well. We have a parent, this picture is unfortunately not so clear, but there is a parent that was helping us out set up the school. He was holding the phone so that we could get internet data to be able to upgrade some of the software that we needed because we had incompatibilities. And then the dancers here, that's part of the festival of the Guelaguetza, which represents the exchange of gifts is not the right word, but the exchange of goods in, with services instead of a monetary transaction. All right, so how does Kids on Computers make it happen? So, can you, yeah. So, I'm trying to find an arch on why this method works. And the whole idea is to be able to engage with the communities in a long-term commitment to education. So the way it works is we either the schools request or we identify schools or we have some sort of connection with the schools that need the computer lab. And there's a certain level of requisites that they need to meet such that we decide to engage with them. In particular, the safety of the equipment, so meaning that at least there is a room that can be locked so that the equipment is not stolen. And also that there's going to be a person, a point of contact that will be in charge of making sure that the computer lab keeps running throughout the years. And obviously, Kids on Computer tries to keep in communication with our point of contact through WhatsApp or text messages, whatever is available for this point of contact to provide some help. And also, we go back to these schools to give maintenance to the schools, to the equipment, and all right. So the other method, the part of the method of making these computer labs work is also we engaging with the offline software community, the open source community that is working on technological solutions to provide education offline, like Internet on the Box, Wikipedia, Khan Academy, KA Live, Kiwix, the content itself, right? Everything needs to come from somewhere, and all these efforts are community efforts. And that's the communality and that I see at large, and that allows us to have a long-term commitment for education. And if you want to find out more about us, this is the website. And yeah, if you have any questions later, I'm happy to answer.
Hello, I am Josh Dennis. I've been working with a charity that is actually based in the UK called 100 Schools. We've been building schools in Myanmar from the ground up since 2006 was the first school that was built. That was before my time with them. We built 55 schools in rural areas. So it was founded by, this is Mangman G, he's climbed a tree in order to find cell phone service in one of the locations. He's sort of the Adam Holt of Myanmar. He's generally got a cell phone attached to his ear most of the time. And then John at one of the opening ceremonies, who's an expat Canadian. And John was in Myanmar in 1996 as a tourist, and Mangmanji was his tri-shot driver around Mandalay. And when it came time to pay him, Mangmanji said, "You visited my parents, I can't take your money, we're friends now." And John asked him, "Well, what can I do then? What can I do for you? I'd like to do something." And his village needed a pump for their well. Before that, they were hand bombing all of their water from the well. And so John went into Thailand, bought a pump, came back, installed it, and now they've got irrigation in their village. And so they started to put these pumps in other villages, and from there they moved into building schools and creating places of education. There's a triage that goes on. There's many locations, areas in Myanmar that are looking for new schools. And so this would be an example of a school you could go to, and you can see the roof, there's holes in the floor, the pylons, you can't really see it, the pilings on the bottom are rotting out. And so in a place like this, that school would be torn down and a new school would be built. 2 layers of bricks for the walls. We have a crew that goes through and builds all of these schools, very efficient and very high quality work. And then the smaller building there was a teacher's quarters. Once the schools are built, the government provides the teachers, and we build the house for them to live in. The community is also out in force during the construction, which gives a sense of ownership and pride and helps out the speediness of construction overall. There's the front of a finished school. We also provide the desks and chalkboards and school bags for the children after the construction of the school. And also uniforms and notebooks. The uniforms are generally the best piece of clothing that these children will own. And you can see Bangmanji on the phone again. After the schools are built, then there is a transfer of ownership. It's hard to read, but these are 6 promises basically that the community village is going to make. And there are things like we promise to have our children go to school, respect the teachers, keep the school clean, maintain, and then John will transfer over the title of that school to the actual village. There's also build outhouses. A lot of times the children would just go out and go outside and find a spot, and that's where you do your business. So we put the outhouses for sanitation as required by the government per students attending the school. Also have built a couple of clinics in these rural areas with the promise that they would be supplied with health workers and medicine. So that's kind of another element that we're working into. And then the schools themselves are used not just for education, but as a meeting place in these communities, as it is generally the best building in that village and most villages around as well. And recently there has been a cataracts clinic held in one of these schools. And now we're working on putting computer labs. There's been 55 schools built. I was over in December and deployed the first computer lab in one of these schools. And you see John and Mangmanji on the end, and then the 3 young adults in the middle are going to be the IT department for 100 schools, and we'll be doing future deployments and maintenance and just general IT. That's an electrician. They don't all look like that. And then that's 5 of the 6 client computers. The entire lab was built out of Raspberry Pis, which I transported to Myanmar, and then everything else was sourced in country: the monitors, keyboards, mice, UPS, printer. And one of the exciting things that didn't really foresee necessarily was adults are starting to use these computer labs in off hours, evenings, weekends, and are being trained. And I mean, it's once we started putting these computers in, you couldn't get out the door. The kids were all in the windows, doors, just waiting to get in. So yes, there's a couple of websites, 100 Schools, and You Are Building Knowledge. I also work with, and we raise money to send over there to help with the schools as well. Generally, we go over, we buy handicrafts from local workers at a fair price, bring them back to Canada, and sell them at craft fairs, and then take all that money and send it back as well. But anyway, thank you.
I've been involved with this project for a little more than a year and a half. I met Adam at the Scale conference in Pasadena, and the idea was that people like Cesar and Josh, they need to have copies of Wikipedia that they can take with them to these remote places that have no internet, and make sure that they have information they can give to people that is the Wikipedia. With, of course, the caveat that if you have a gigantic SD card, then you'll get mugged and robbed because it is the most expensive thing they've ever seen. So 32 gigabytes is about the right size for one of these things. And so I've been involved in shrinking Wikipedia, selecting subsets of Wikipedia for a year and a half now. And my talk is about the various different ways that multiple teams can work together while being remote from one another, so that we can provide this information to people who are going out into the field. And also at the same time making sure that we can do all this work not necessarily having even seen each other face to face. So there's a couple of different tools, modern tools for doing this, and one is called Docker and the other is called Vagrant. This talk is designed around people who are not particularly familiar with either virtualization technology, so if you already know all of this stuff, then I apologize, but I hope that it will be useful for you. So let's go to the next slide. So the problem here is there are many problems when you're doing remote development. When you have people in different time zones, we have people who've never met each other face to face. We have people who maybe are even on different continents. Where English is not their first language or French is not their first language. These can all be tricky situations to solve. And frankly, that's well beyond the scope of this talk. But a really, really big important thing to solve is the ability for everybody to have the same development environment, right? If somebody's running Linux on one machine and somebody else is running Windows on another machine and somebody else is running on a Mac and the Mac is running OS 10.7 and the Windows is Windows XP or whatever, you have this wide variety of different machines. It becomes very difficult to actually get any forward progress because you'll find that, oh, it works on my machine, oh, but it doesn't work on my machine, and you spend most of your time trying to get everybody to just get things to work. You also have the problem of, well, I have this code from 5 years ago, it worked 5 years ago, but now operating systems have changed and it doesn't work anymore. Well, how can we make it work from now on out? So this manifests itself as this idea of environment management. We have development environments where individual programmers are trying to get work done, but they may have different OS patches, different library versions, different versions of programming languages, all kinds of things happening. You're going to have people who are trying to test the code. Before Josh and Cesar are going to go and deliver stuff to people in these remote areas, we want to test it to make sure that the trip isn't going to be wasted. And if they can't test it, then it doesn't help. And we need to be able to easily, rapidly, and automatically deploy new systems to these guys so that, if they're on their way out the door, we can easily make sure that they have something that actually works and have confidence that it will work. So the general solution to this is this idea of virtual machines. And for those of you who are not familiar, we are going to start on the left with, on the left you have a very traditional, broad view of what a computer is. And I'm assuming everybody in this audience, who has some programming experience understands the left. That you have an operating system. The operating system, through the kernel acts as an intermediary between the hardware and the software that is your apps. And with virtual machines, you can have virtual representations of your operating system, and well, it's actually a real representation of your operating system, and virtual graphical processing units, virtual CPUs, et cetera, in different apps. So you could have Linux and Mac and Windows all running together on the same physical piece of hardware, and each of them having different ways of interpreting how to talk to that hardware. So that's very interesting and very useful. And how it solves the environment problem is that the entire environment here, everything about this virtual operating system can be prepackaged and predetermined. You can figure out your operating system, you can figure out your patch level, you can figure out your library version, and you can put it all together, and then it becomes one giant number. A number that is gigabytes big, but it is essentially one giant number. And that giant number represents the state of the computer as you want it to be. And that can be checked into a repository just like code. And when you turn it on, it solves the but it works on my machine problem, right? You have a virtual machine, and if that virtual machine works, then anytime you have that machine running, it will work because you have already set everything up. You set the state of the machine to where it should run. So your test environments, your production environments, these can be easily replicated, or you can make multiple copies of each one of your operating systems and run it on different machines. And so now you can scale things up very, very rapidly. And a real-life example of this is AMIs, or Amazon Machine Images. They're virtual images that can be instantly attached to hardware in the Amazon cloud, and then you can turn it on. So if you want to have 40 machines all running the same piece of software, it's very straightforward. You put together an AMI and you distribute it that way. Is my screen coming through? We all good? Yeah. Okay. What are the drawbacks? You have a giant number. And so that could be very, very large, very unwieldy. If you're on a slow internet connection, you don't have a terabyte or gigabyte download speeds, that's terrible. There's a large amount of storage needed for these types of repositories, and unless you're backing something with S3 or some other cloud-based storage solution, you're going to run out of room very, very rapidly. You also have this problem, and you can tell that developers in the development community are not, especially who are doing this, they're not necessarily Hindu, because we have this representation of the idea between pets and cattle. The idea is that a pet is something that can exist for all time. Like, it exists, but when it dies, you lose something, because the pet has, it's become part of you. You have an emotional attachment to it. Whereas cattle, you don't care. You kill it whenever, and you bring another one back, and it's just one after the other after the other. And when you're doing these types of development environments, you don't want to have pets. You want to have cattle. You want to have things that can die and be brought back to life. Well, if you have a virtual machine that is very hard, very large, and very unwieldy, there's a tendency to just stick with one virtual machine and keep it around, and then you start installing new things on it, you put patches on it, and now all of a sudden it becomes a pet. It becomes a very difficult system to maintain. And that means that you have no real audit trail for creating your virtual machine, right? How did that machine get to be in the state where it is? Well, if you have an AMI, you have an image, but you don't necessarily have a way in which that image was created. And you also can have this problem where, the actual virtual machine itself, built by some piece of software, VMware, VirtualBox, Zen, there's all of these different types of virtualizers, and they can all have their own subtle different quirks about how they access memory or how they access a GPU that can change as the underlying host system changes. So now you have this problem where all you want to have NumPy available, and you want to use NumPy, version 0.11, and you want to have Python 2.7, and those are your real dependencies. But because you built your virtual machine on, VMware 2.0, and it's, now VMware 8.0, you're hosed, right? So these are things that these are real problems with developing monolithic virtual machines. So then we start with Vagrant. Vagrant is basically it's a project under active development from a company called HashiCorp. You just search for Vagrant, and you have to search for Vagrant virtual machines, because if you just search for Vagrant, you're going to get pictures of homeless people. And the idea is that you have a script for setting up your virtual machine. You're going to provide a basis. You want an Ubuntu 16.4. You want a particular AMI. You want Windows servers. You want a Mac OS server version, etc. You say, I'm going to give you the basis. You provision the machine, which means installing all the other subsequent programs that you need to actually do things. And you have a recipe now. So, you know, a new version of Ubuntu comes out, right? We're going to have 18.04 in a couple of months. But maybe what you're working on only requires 16.04. Well, this way you can guarantee that you have everything set up to where it needs to be. It's locally accessible via SSH, and it's in the same directory as the source of the program you're trying to work on. So in two directories, you will have, in the same directory, you'll have your Vagrant instance, and it will share the file system with the code that you are editing. So you can edit the code, and then inside the Vagrant instance, you can see how that edit affects the code's behavior in the environment that you want it to work in. And it works on top of all sorts of popular virtual machine packages, VirtualBox, VMware, and Docker, which we'll talk about in a bit. So here's a sample Vagrant script. This is from the Drop Wizard repository. It's actually 3 years old, but it still works just fine. So what you see is, at the top, we're configuring the operating system. We've decided that we're using Ubuntu 14.04, 64 Puppet. This is a particular flavor of Ubuntu. So you're using the image that they've created. You're setting up your networking. So if you want to set up IP addresses, you need to change your IP tables, you need to change file handles, etc. You can put all this in here. You have provider-specific VM configuration. So if VirtualBox is your provider, limit this to 256. If VMware is your provider, you can do something else. You can also change your CPUs. You can change however you want the machine to be set up. I often like to have my Vagrant set up with 3 CPUs on a 4 CPU box. That way I have 1 CPU left over in case something goes bad inside the Vagrant. And then you can provision via the shell, where you can have lots of inline scripts here. This one, they're only doing apt-get update. And then they're doing Puppet as their provisioner. Puppet and Chef are different provisioning mechanisms, and those all run within Vagrant. So the idea here is that suppose my Vagrant gets out of whack. You know, I'm running along, and all of a sudden I've corrupted something, something goes haywire. I can just kill my instance, or I can kill the entire Vagrant and then restart it and bring it back to the same state using this Vagrant script, right? So I have some cattle. I don't have a pet. It can be dead. And I can also hand this to Tim Moody. I can hand this to Adam Holt. I can hand this to anybody else, and they can run Vagrant, and they can have the exact same setup that I do, so long as, of course, they could reach the Puppet. So we have a lot of advantages here. Right? We have one script for everybody who wants to use the program, and it's a known environment. We have fixes that are environment-based, like file handles and IP tables and stuff like this. For those of you guys who don't know, file handles is one of those things where the default is like 1024 on a Linux system, and if you try to have more than 1,000 files open at a time, you will break yourself, and that tends to be a huge problem with any web application where you have more than a couple of requests per second. You can easily kill a current image or an old image. You just delete it. You can debug through the command line very readily because of that shared document directory structure. And you can check in your file into a source code repository so that other people can run it. And you can also put as the foundation, where right here I have this foundation is VirtualBox. You can actually back it with a cloud instance from EC2 or Azure or some other cloud provider that runs on the bare metal. Like it'll provision right into the bare metal rather than running as a virtual machine. And I've actually seen this done with an ETL system, a business level ETL system for extract, transforming, and loading. Literally millions of lines of code, millions of lines of log files that are coming in to the tune of a couple of billion per day have been deployed using systems like this. The disadvantages, though, is that building an image could take quite a bit of time. This provisioning file is actually calling sudo get update, and you have to do this every time because of the way that Ubuntu works, and this could take some time. And same with Puppet, you know, running Puppet. It may compile something or run something there. So you're downloading a lot of code to install a virtual image, and you can have redundant code between images, where you have two Ubuntu images that are doing two different functions, but they all have the same basic thing, and so suddenly you've got two different 5 GB images when all's said and done, and each of them require a long time to build, and that can be a huge pain. And like I said, you can provision for production deploy, but that Vagrant file was like 300 lines long. It is non-trivial to set that up. So let's talk about production for a second. Is everybody cool with where I am right now? All right, cool. What we want in production is that we don't want to be replicating all the operating systems. We don't want to be sharing duplicate files across images. We don't want to have multiple kernels running at the same time on top of a different operating system level kernel. We want to have one kernel. We want to have those file handles and IP tables and other OS level dependencies. We would rather have them hidden and have multiple Vagrant images. If they are running on the same box, that IP table fix for the virtual image actually doesn't solve the problem on the base box. So now you've got this problem where you've abstracted the problem out of the base box, or out of the virtual box, but the base box still has the issue. And then the other problem is that because they can be very lengthy to put together, you do still have the problem of making pets versus cattle, where you keep editing something because it's super convenient. The edit then see the results cycle is very, very quick. It's as fast as if you're editing on a regular machine, not in a virtual machine. But that can cause you to forget that you installed something. Forget that this package was installed. So now we enter with Docker. Docker is also, it's a tool for creating locked images very, very easily. It is a scripting interface very similar to Vagrant. It's generally Linux-based for the same reasons Vagrant is. You have licensing issues with running multiple Windows machines or Mac OS machines. Linux, you have no licensing issues. You can create a provisioning script inside the Docker file. And this is key. You have a one-to-one relationship between the app and the container. So if you want a Redis, you have a Redis Docker, and you just set that aside, and all that does is it does Redis. You want a Postgres, you set aside a Redis Postgres, and that's all it does. And how big do you want that Postgres to be? Well, then you put it on an M4 10x large, you put it on an M4 16x large. These are all EC2 instance sizes, and you can make decisions about how many CPUs you want to dedicate and so forth. But you have this functionality that is distinct from the hardware that you throw it onto. And there's no real way to have pet here. Like everything is cattle. Everything is killable at any instance and replaceable with anything else. So here's a sample Docker file, and this time is a Node.js one. You're doing from Ubuntu,
time check.
From Ubuntu 16.4, etc. And then you can reprovision everything here. And then finally at the end, you see your command. And that command is what you run. And you only are running one command per container. There are a lot of differences here. The cycle to code, test, and fix takes a lot longer. You have lots of coordinating images for multiple images together, Rancher, Kubernetes. You can have software as a service for Azure, ECS, which, so on and so forth. And you could share those kernels and system resources. I'm going to go pretty quickly here. So which one should you use? And these are the sort of checklist questions that I look at. Are you developing products that go on servers that have monitoring and nobody logging in? Do you constantly tinker with your code? Are you orchestrating multiple components? Do you need to have a Redis? Do you need to have a database, multiple different types of databases? Do you need to have lots of microservices? And what does your production environment look like? And what are you giving your end user? For us, we're giving people on Raspberry Pis. So maybe we just have one Docker image that runs on top of a Raspberry Pi, but it has just one application in it, and that is a Zim file that's been created with WikiSelector or whatever, and Reno's code to put everything together. So what does that look like? And for us, it's a single application. Finally, do you have a testing suite? And what do they look like? Do you need to know the internal state of your system? If you do, then you need a Vagrant. But if you don't, then you need a Docker. And then you can use a hybrid. I use a hybrid where I develop on Vagrant, and then I move into a Docker when I have everything is squared away, so that when there are bugs that arise, I can debug on a Vagrant, and then I could just rebuild my Docker. And then that way I can know if I have tests for both, I can run my tests on the Vagrant and then run them on the Docker and make sure that everything is good. In the future we could talk about, maybe next year, microkernels, where you take out portions of the operating system you don't use, which has a very high increase in efficiency. You have a much lower attack surface, which I don't even know if we need to know about that in this particular context. And you can also provision Vagrant on your Docker images, which is a relatively new piece of functionality. And this you have true combination between the two. So anyway, that is this talk of how do we get code into the hands of Josh and Cesar so that they can deliver things to these remote villages.
Hello everybody, so I'm Guillaume Thiolliere. I will talk about the PiBox installer. It is actually an installer to turn the Raspberry Pi into a Wi-Fi hotspot with the content on it. So I think all of you are aware about the internet access around the world, so I will skip this slide actually. I am an intern at Kiwix, and this internship is mainly financed by the Holland Foundation. So the Holland Foundation builds schools in the global south and in Africa also. This is a picture from Madagascar. They build the schools and they pay the teachers and they give to the students low-end hardware that are tablets. So we need a way to give the content to those tablets. Currently they have a Raspberry Pi, they configure themselves with the content with Kiwix inside, Kalight and things like that. But they do that by hand, and the goal of the project is to have an installer that makes it easy for everyone to create those Raspberry Pi. So this is the solution. Currently it is working. There is a PiBox Wi-Fi network. You can connect to it, and we will have the direction to the main page and have access to the content. So the content is done locally. It creates a Wi-Fi network, and inside actually it is not Kiwix directly or a third-party application. It is IDSCube, the central servers that give access to the other software. So this is the main interface. It is actually IDSCube, and there is a Kiwix inside, so you have access to the Wikipedia things. But there is Kalight that can be put on the Raspberry Pi, and any kind of third-party application can be connected to the IDSCube interface with configurations. So now we'll talk about how the PiBox installer works. So the main goal is to have this that is straightforward and that doesn't require any skills. So it is. You can download it for the mainstream platform Windows, Linux, and Mac OS. You plug the SD card to your computer, you launch the program, and then you choose the content. You launch the installation, but it can take several hours, like 10 hours, depending on the connection also you have and the size of the SD card you want to build. The installation doesn't require any input, you just have to wait for the end. And once it is built, you get an image that is working out of the box. There is no further configuration. This is the interface to see that it is usable. Inside Raspberry Pi, it is actually IDSCube the main server. There is Serve and also other applications that can be put on, such as Kalight. Also a flat-tune that is kind of Kalight but for younger people. We're on Wikimania. It has been presented yesterday. Yes. So the IDSCube server is mainly a Django server. It is used by BSF, and they actually formed the project. BSF is Library Without Borders. They use that in area such as refugees camp and other in Colombia also. Now I will dive into the details about how the installer works, so it is more technical. This is a Python application. I use GTK for the graphic interface because it's cross-platform. And the packaging is just used with standard tools of the Python ecosystem by installer. And I use an emulator. I will explain why after. That is packaged by hand actually. So the installation process, I use as a start standard Raspberry Light image. It is an image for the Raspberry Pi. It is made by the Raspberry Pi Foundation actually. Then I resize the image so that it corresponds to the size of the SD card with KeyImage. It is a tool provided by KeyImage, but it can be made with other tools also. And now this is the central point. It is the emulation of the Raspberry Pi. Because we don't want to have the user to connect the Raspberry Pi to the computer, we do everything on the computer of the user. So you emulate the Raspberry Pi, and we will do the configuration of the Raspberry Pi inside the emulation. The emulation of the Raspberry Pi is not straightforward, actually, because here you have a Raspberry 2 machine, but it is not complete. So we can't use it because there has no network access inside the emulation. So we use a standard ARM version 7 machine, that is a Versatile Express, and we compile a kernel for that. The configuration is in the makefile of Linux, actually, so it is very easy to do. We cross-compile it for our LM. The second point is how we communicate with the emulation. Because SSH is not activated by default inside the Raspbian Lite image, we have to find a way to activate the SSH, and then we connect by SSH, and this is very standard communication protocol. There is two possibilities. We can add an empty file at the boot, in the boot directory, or we choose the other alternative. It is to use the standard input and output of the process to actually enable the SSH protocol, and then we can use SSH because it is more robust. From SSD in and SSD out, we just have to wait for the prompt to appear, and then write the command. It's not robust because the prompt can appear in an output of a command or things like that. So we use SSH after all. So inside the emulation, we just resize the partition on the file system. And then we have all the configuration of ID's cube and the installation of zip files inside. We use actually a playbook that uses Ansible, which is made by BSF actually. So this playbook is named Ansible Cube. It is made by BSF in order to deploy their configuration to the Raspberry Pi for all their refugees camp and all the configuration they want, actually. So Ansible is a way to deploy things with a configuration. Actually, it is a layer on top of a shell script that is just YAML rules. So it is for ease of maintenance, actually, or things like, yes, it's a maintenance. And it looks like that. So it's not very difficult to write, and there is a lot of things that are common with shell scripts. So it is the end of the installation process. We just then write the ID script specific configuration and write the image to the SD card. Yes, that's how it works.
What platforms are you supporting for creation?
Windows, macOS, and Linux.
Via cable?
Yes.
It's a question for Mark online. When you were talking about the virtual machines, I was just wondering if this might be a way to introduce updating of PiBox instances.
Yeah, I think that would be. Yeah, I think that would be very useful, especially if you have a self-contained, if you have a Docker that's running a KeyWix instance, and then that way you can make sure that it's always doing what it's supposed to be doing, regardless of the operating system it's delivered to. That's sort of what I mean when I talk about production level code, right? That.
I mean, updating the content.
Yeah, so it's when you update, if you're going to update the content remotely, then again, you want to be able to make sure that the remote update works, right? So if you have you have the code that does the work, and then you have the content that can be distinct from that code, right? You can package it all together, or you can have it run distinctly and just have the Docker access a remote or even internal file system. But it's the best way so that we don't all have to develop on Raspberry Pi to make sure that stuff actually gets delivered. Did that answer your question?
Yeah, I'd like to ask Cesar about the what would you see are the future needs? I'm someone who's interested in putting together content. What are the needs, do you think, of the future? Do you think science lab simulations, what sort of educational resources are most needed?
So for people watching the video later, the question was, what are the needs in regards to how to choose the content, if I understood correctly. The way we have gone about it is, first of all, just free form. We know about open source educational applications or open source, freely available content in Wikipedia, Khan Academy, etc. And just put it in place. It's like put everything in there, and if you have people that know some of them, train the teachers about it. Now, the more involved mechanism is you engage with a domain expert on education, on the curriculum in the country, and go through what could be considered a painful and labor-intensive effort of choosing exactly what is required for the school level that you're targeting. So in particular with Internet in the Box and my father who is a teacher, we were able to narrow down the amount of content that we needed. We'll see how that results. The deployment was 2-3 months ago. So probably maybe next year or in a few months we'll have some results.
In Myanmar, it's a bit different because there is quite a bit of Spanish content around, whereas content in Burmese is much more scarce. And so I think one of the biggest challenges right now is having content, either original content or translated content produced in the Burmese language. So it's been a pretty closed country, as many people probably know, for decades, and it's recently opened up in the last few years. And so now that spread of data and just the openness to create more data and let outside influences or outside people curate or translate data is becoming much more proficient.
Cesar, I wonder if you're able to comment a little bit about the recent alliance with the university and the computer science students there. I think that's a really innovative addition to the Kids on Computers program.
Yeah, thank you, Tim. I skipped one of the pictures that I was showing was we were with authority, I forget which level of the university, but what Kids on Computer did was to, again, partner with a local university in the region of Oaxaca and to establish a social services program that will provide with students that will be helping the computer labs that we set up to keep running smoothly, to perform quality assurance on the content and the software that we provide. And yeah, that's gonna be a really helpful mechanism that will allow us to make sure that this project keeps going and is successsul in the long term.
Question for Mark that is ill-constructed, but forgive me, I got yanked out of the room with a phone call while you were speaking. we might have an astonishing offer from archive.org, which, as you know, is Internet Archive, to host a lot of Internet in a Box images. When we talk to them later this afternoon, we might get a little greedy and ask them to host live images. What would be your recommendation, Mark, for of the various VM, whatever, Docker, Vagrant technologies that we should be pushing for as they, the cattle versus pet issue I don't understand, but we'll certainly have both kinds, where some of them will be changing constantly and we'll get too esoteric and misunderstood and some more mass market versions. Anyway, they're going to have to define the constraints, archive.org, but how should we begin that conversation?
I think that we have to begin the conversation with them about how they present content to their users, right? Because if they have dedicated servers that are for individual images, then probably either of them will work. If they, I'd have to see their particular setup, because it also depends on how they do their logging, how they do. So when we talk about pets versus cattle, the idea is that your laptop, your personal laptop, is a pet. It's got data on there that's specific to you. You could not replicate that laptop easily in its current state, right? The operating system, you patched it, probably you don't remember what all the patches are, probably you don't remember all the programs you've installed, the versions that they've been installed under, whether or not they are patched up to the right amount of so because you can't replicate it, because you can't audit it, that's a pet, right? And so when you're trying to put things into a state where you can distribute it to everybody, and you don't care if that thing lives or dies, it's not, you don't have any information on it that's particular or special, then it becomes cattle, right? And so the cattle is probably what we want to give to them, and it's just a question of how we do it. And that's going to be on them that's going to have to be part of the conversation, is how do they want their data to be, how do they want to represent this data or serve this data?
For Guillaume, you talked about content selection at the top level of your presentation. But then mostly you talked about provisioning the actual image as opposed to which ZIMs do I want. Can you say more about content selection and how it gets integrated in? And also, if I look at the PiBox that's running in this room, everything is running on Kiwix. So what about other content sources, maybe static HTML, maybe KA Lite or Libri, other kinds of things that maybe are actually a separate server from Kiwix?
So the content available is, I would say, there's a lot of ZIMs, but there is also a third-party application, there is Kalites that can be installed. It is not yet released, but Wikimania and Aflatun are also will be also installable in the next version. And there is a static sites that BSF have made in their catalog. So yes, mainly ZIMs on the Kalite, Aflatun, Wikifendi. Colibri is also planned, but I don't know if it will be shipped.
So the question for Guillaume. It's a PiBox installer, but there's a few people in this room who talk about the Napster of Alexandria. The Napster of Alexandria, or the SneakerNet of Alexandria. Is that something that you could consider more side-loading when you're installing? Could that be installing after the fact, or is that not something you're thinking about just yet, and removing ZIMs, adding ZIMs, etc.? Not yet.
Not yet, at least.
Thank you.